In the previous chapter, I talked about batch processing and how we can use AWS Glue as a serverless hosting platform to execute data transformations either using PySpark or using Glue API. So it was only about batch processing. I had shown you how we can read from S3 files and then load it to OLTP databases like MySQL. Also, I had shown you how you can read from OLTP databases, do some transformation and load it to data warehousing system like Redshift. But in today's connected world, we cannot do away with stream processing or real-time processing. Real-time processing is more so important today because, as customers, we are getting more and more impatient because of the technology and the speed of internet around us. And there are a lot of devices, there are a lot of applications which generate real-time data. Only data generation would not help. We'll have to capture the data to do some real-time processing also, or we have to ingest the data. So that's where AWS has Amazon Kinesis service, which is used for streaming ingestion. So first of all, let's talk about what is streaming data. There are certain pointers or there are certain one-liners which can be used to define streaming data in its entirety. The first one is continuous flow. When I say continuous flow, it means that data would keep on coming forever. It will not stop. That would be known as streaming data, which is coming continuously. So if one device fails or if one application fails, data would be sent from other applications or other devices. That's what continuous flow is, which never stops. The second one is unbounded. Why it is unbounded? Because we do not know when the data ingestion or data streaming started or when it will end. Let's consider temperature sensors around the world. So there are hundreds of thousands of temperature sensors or earthquake sensors around the world. And it is highly unlikely that all those hundreds of thousands of sensors will stop at the same time unless you have an electromagnetic pulse which will stop all the machines which are there in Earth. Obviously, that's a joke. We cannot have an EMP which can take out all the machines in the world in a single go. But what I'm trying to say here is that if let's say some of the devices fail, let's say thousands of devices fail, even then 900,000 devices or other 90,000 devices would be there and data would be keep on coming. So there is no way to know when the data started and when it will end. So that's why it is called unbounded. Obviously it started at some point, but after that it never stopped coming and it is coming continuously. So there is no particular size to it and there is no particular end to it, unlike batch data. In batch data, let's say if we deal with files, it can be CSV files, Parquet files, Avro files, or OLTP databases or data warehousing systems, does not matter. We know the size of the data. We know how much data we are dealing with, either in gigabytes or megabytes or in number of records. We can quantify the data which is there in any of these systems. But in case of streaming data, we cannot quantify it because, as I said, we do not know the start and we do not know the end. We can say that in a single day, this much amount of data we can expect, but that is for a single day and it will keep on coming. So that's why streaming data is unbounded and it is of high volume. It can be of high volume, meaning that the amount of data that is being sent or that are sent can be of huge size. Along with that, it has to be near real time or real time. There's nothing called real time as such because there would be certain latency that would be involved. Let's say I'm generating some data here in Bangalore, India, and it is getting stored in somewhere in Mumbai. So obviously there's some time between the data generation and the data ingestion and data processing, unless the data that I'm sending is using quantum entanglement, it will not happen. So that's why even though it is known as real time, but actually it is near real time. And the biggest challenge is that all these data have to be ingested and stored for processing. We cannot process a data without storing it. So the question is where to collect and store such huge data temporarily. Why temporarily? Because we do not need to have the data continuously. Imagine that the temperature sensors are sending data continuously for the last 10 years. Maybe we do not need the data which are older than 2 years or 3 years or 4 years. At some point in time, the data would become irrelevant. So that's why, irrespective of the number of years, data is temporary. So you'll have to collect the data, store the data temporarily. Now, the number of years that I was talking about just now, whether it can be 4 years, 3 years, that is the data after processing. We store processed data for some time, but the streaming data that we ingest, we cannot store it forever because we'll have to process it, store it somewhere else after processing, and then we'll have to discard the data. So that's why streaming data is temporary, first of all, but it is huge, it has high volume, it is unbounded. So where do we collect and store such huge data? Of course, you might have guessed that a single server cannot handle such ingestion rate, such volume or velocity, and cannot provide the amount of storage that is needed to capture and store the data. So that is done by distributed storage in the form of message broker. Now, when I say message broker, by message I mean this data or the records that are coming in. It has to be stored in a distributed fashion because a single server cannot handle it. It has to be stored in a distributed fashion. And that's where AWS provides Kinesis, and there are multiple products of Kinesis, but the most famous products that is instrumental in serverless data processing in AWS is the Kinesis data streams, also known as KDS, and Kinesis data firehose, also known as KDF. So Kinesis data streams is KDS and Kinesis data firehose is KDF. I'll talk about both Kinesis data streams and Kinesis data firehose in this course. So at a high level, what this Kinesis data streams is. Kinesis data streams is a logical grouping of multiple shards, or as we know it, partitions. So there can be multiple partitions. When I say partitions, these are storage partitions along with compute. So as you can see, the partitions are meant to be stored in different servers. The Kinesis data streams is a logical grouping on top of the partitions, and there can be thousands of partitions. Of course, we cannot have all those 1,000 partitions in a single machine. Let's say one machine can store only 10 partitions, then it would need at least 100 servers. And the streaming data would be sent to these partitions, and they would be captured to be stored temporarily and processed.